We recently graphed a exponential function where the base was greater than 1. And we saw that characteristic exponential growth function where we're hovering along the x-axis and then zoom, we take off. And in this case, we've got b, our base, is greater than 0, but it is less than 1. And we're seeing 1/2 raised to the power of x and then minus 1. Now, this 1/2, when the base is greater than 0, less than 1, we actually have what we could characterize as an exponential decay function. We'll learn the difference between growth and decay functions. But just to give you an idea of what that function is going to do and how it's going to be different, it's actually going to be reflected or flipped across the y-axis, and it's going to be characterized by something that looks more like this right here. And being that, and what causes that is this base being, again, it's greater than 0, but it's less than 1. Now, also in this particular function, y equals 1/2 raised to the power of x minus 1, we also see another transformation, which is this -1 is going to cause this graph to shift down by 1. So rather than hovering or having a horizontal asymptote at the x-axis, we're actually going to see a horizontal asymptote that's going to occur down here at -1. And so our graph really at this time is going to come, it's going to pass through the y-intercept, and I'll talk about that more in a minute, is actually going through the origin. And so it's going to come and look something maybe more similar to that. So that brings us kind of, I guess, to the y-intercept. Again, if I'm algebraically going to find the y-intercept, I set x equal to 0 and solve for y. And so here I got 1/2 raised to the power of 0 minus 1. And, well, anything, again, raised to the power of 0 is just equal to 1. And so we'd have 1 minus 1, or we have a y-intercept at 0, or when x is 0, y is also going to be 0. And that's because of this vertical shift, this -1. Now, what about our domain and range? Well, again, I really don't have any restrictions on the domain. So my domain is going to be all real numbers, or I could say that the domain is equal to -infinity out to infinity. But my range, again, I do see some restrictions or constraints on my range. And if you notice, I'm going to get very, very close to -1, and we'll see this more clearly when we graph this on the calculator. We'll go in and look at the table, but it's never going to equal or be less than -1. So my range, we might say, is equal to y such that y is greater than -1. Or we could write it as just simply our range is y is greater than -1. All right, well, let's move over to the calculator. We're going to graph this as something special, or maybe in particular I want to show you when it terms of graphing that has to deal with graphing that 1/2. Let's move over there and we'll proceed. All right, we're back on the calculator. You can see where previously we graphed 7 to the power of x. This time we're going to graph 1/2. I want to tell you it is always a good idea to put these fractions, these rational expressions, in parentheses. And you notice I put parentheses, 1/2, close the parentheses. You need to do that. And then I'm going to hit caret x because we're dealing with an exponential function. My variable is in the exponent. And we got our -1. So we got 1/2. Again, we should see this reflect across the y-axis. We should see our y-intercept go from at 0, 1 down to 0, 0. Our domain is going to be negative infinity to infinity. Our range is going to be such that y is greater than negative 1. And we'll take a look at the table, but first let's go glance at the graph. And there you see, it has been reflected across the y-axis from what we saw previously. And we see that we've got a horizontal asymptote right here at where y equals negative 1. We get very, very close to negative 1, but we're not ever going to equal negative 1, nor are we going to go below negative 1 in this particular function. That vertical shift, that negative 1, pushed this down by 1 unit. Let's look at our table. And I can see that if I go down here to when x is equal to 0, I see that we got a y-intercept there at 0. Y is equal to 0, so there's our y-intercept. And as x is getting positive, I can see that that's negative 0.5 when x is 1. When x is 5, it's equal to negative 0.969. That's getting closer to negative 1, but it's not negative 1. Let's go down. We'll look at a few more. When x is equal to 10, we see that y is equal to negative 0.999. We're getting really, really close to negative 1, but it's not ever going to equal or go below. Let's go look at some of our negative exponents. Remember, I got 1/2. If I got 1/2, and I should have probably done this on the previous screen, what's happening? If I got a negative, then it's going to be 1/2, let's say, to the negative 5th power. Well, that actually flips up my that 2 from the denominator and moves it into the numerator. And so x equal to negative 5, y is going to equal 31. That's because x to the 5th is 32. And then, of course, we got the minus 1 out there, which takes us to 31. All right, well, there we viewed where b is greater than 0, less than 1. We see that reflection. We also had the opportunity to see a vertical shift down 1, which changes our intercept and changes our range. Domain remained the same, negative infinity to infinity.